Very good morning.
Good morning, sir.
Is what happened, Anand Modi? Okay, how was your experience with the festival Diwali?
So we had a hell lot of assignments, so couldn't even celebrate properly.
Uh, concerning the classes, we alone have the classes, isn't it? Any other subjects faculties handling the
So,
classes? I think
so
all are
for,
completed.
for yes, sir, mostly everyone has completed. Only forming two classes are left.
Okay, okay. By this, by the forthcoming week, we will plan to complete our syllabus.
Okay, sir.
Anyone stuck with the national disaster? There are a few states where with heavy rain. Uh, anyone's stuck? Have you heard about it? Any of your friends whether they may in numerical methods or in your class the disaster? If no one, then that is good. Okay, we'll start our session. Only 12 people join. Anyway, we'll start our session. And concerning your presentation, everyone did well, and my appreciations to one and all, and appreciation to the team lead, Anand Modi, Bhavya, Rahul, Sabrani, and Nirmal, and you did your duty very well. If it is feasible, I'll consider the presentation in terms with the marks, uh, if it is feasible. Okay, this is what we have seen in the last class. That is Lagrange's formula. Interpolation, the interpolation in connection with your syllabus, we need to start with Newton's forward interpolation, Newton's backward interpolation. That is usually applied for finding the differences when our difference in x is uniform. The difference in x is such in that the Newton's will assist us to find the unknown, but we are a little when concerning the numeric the differences in Lagrange's when we have unequal intervals, the Lagrange interpolation will assist us to find the unknown. Once we are very familiar with the Lagrange's interpolation, then we will have a visit over numerical forward interpolation and numerical backward interpolation. And we'll start with the interpolation with the Lagrange's interpolation. This is what we have seen. The formula which we have derived in the last class is shown in the presentation, that is f of x, and with that we are going to find the unknown. And anyone please suggest to remember this formula in a easiest way, whether it may be with the aid of any acronym, or give some suggestion to remember this formula f of x. I request first top 5 to unmute your mic. Please be with us. Abhishek, Abhishek, number 1, number 3, Abhishek, number 6, Amula Sticker, number 8, Anand Modi, number 11, Ananjya Singh. Please unmute your mic till the session and please join with us. Arvind, you can also join with us. Arvind Roshan. Arvind. Savarni, it is audible. The presentation is visible. Savarni?
Yes, audible and visible.
Okay. Now, okay. Suggest some keys to remember this formula, Savarni.
So like in every, like with every addition, the y value will change, like from y0 to y1 to y2, that way. And like
Okay.
basically we can make the formula in a way that x minus xi summation divided by xi minus 1 minus xi summation into yi.
But in the case of didn't have x minus x naught in the numerator, and
Yes, so like
and this accordingly we
the
should.
term which is there in the y naught, we leave that in the x's value. We won't consider that for the numerator.
Okay.
Excuse me, sir. It's the product, right? It's not the summation. Like the
Yes, of
terms in
course.
the numerator and denominator, they are the
Of course,
products,
of course.
right?
But that was a key.
Mm-hmm.
That was a key to remember. But still, we need to yes. Yes, you tell me some other suggestion, Bhavya.
So suggestion would be the same as she told. I mean, we could generalize it, but that's all I can come up with right now.
Okay, fine. Okay, assume this is the formula. If x by x naught plus x by x1 plus x by and so on plus x by xn. That way, whether we can remember, if the term is y naught, then we need to subtract with x1. If the term is y1, then we need to subtract naught. Similarly, anyway, have your own idea to remember this particular formula. And I have given even I have an idea to remember during the derivation itself. Uh, Please have a revisit over the video and try to remember the formula. And please make a note. This is your example number 1 using Lagrange formula. Calculate for 3 from the following table. And your x and f of x given in the table 0, 1, 114, 215, and 4, 5, 5, 6, and 6 and 19. Okay, and our x naught and y naught similarly till x y and y 5. The tabulated value taken in terms of subscript, and this is our Lagrange's formula. And when we are having y y5, then we need to have we need to extend our formula till y5, and you are having the y2 value y value till yn y your n is equal to 2, then it is enough to keep your y in till y2. Concerning this particular problem, we have our n is equal to 5. Therefore, extend your Lagrange interpolation till your y5. Please make a note. Please make a note. This is the application over the formula, that is we have applied the respective values, that is x0, y0, xn, y1 till our x5 and y5. At first, try to reduce this way of x in terms of x. Then later, you can apply your value of y. From that, we can find the value of respective y value for the required x. And this is what the step-by-step solution over the past step. And we have denominator as -1, -2, -4, -5, and -6. Similarly, for rest are represented in the respective page. And coefficient for the first term is 14, and similarly 15, 5, 6, and 19. And substituting the value of x, we can find the value of respective value, y value. And a of 3 is equal to 12 by 240 minus 252 by 60 plus 40 by 48 by 40 108 plus 228 by 240, having the uniform denominator. By doing simple calculation, we will get the numerator as 2400 and denominator as 240. And by solving this, we can get the OR3 is equal to 10. And the exercise number 2. And to make note that using Lagrange's interpolation formula, find the value corresponding to x is equal to 10 from the following table: x and y 5, 12, 6, 13, 9, 14, and 11, 16. We need to find the value of y of 10. When x is equal to 10, we need to find the value of y. If you feel that we are a little faster, then please have a visit over the video. Then pause the video and note it down the step-by-step procedures. And this is the Lagrange interpolation formula. Then here our n is equal to 3. You start your subscript with 0, that is x0, and x1, x2 till x3 we have data. Therefore, we need to extend your formula till your and this is the given data with the subscript, and our f of 10 is equal to, here I have applied the value of x in the given formula itself. By doing the simple calculation, we will get uh, the value of f of 10 is equal to 14.66. So the yes, please make a note. Arvind Roshan, Anand Modi, Hamala Shrikant, Arvind Roshan, please unmute your mic and please join with us till the end. Anand Modi, Hamala Shrikant, Abhishek.
Yes, sir.
Yes, yes. Shall I change the slide?
Yes, sir.
Yes, this is your example number 3, and using Lagrange formula, fit a polynomial data. Here we have our x0 and x1 is equal to 1, x2 is equal to 3, and our x4 is equal to, sorry, x0, x1, x2, x3 is equal to 4. And the respective y are minus 12, 0, 6, and plus 12. And also find y at x is equal to 2. The Lagrange interpolation formula given, and we have to apply the respective values in the formula. And see here, the first term has the denominator as 12, and here we have 6, and here that too with minus 12, here plus 6, here minus 6, and plus 12. Here we have minus 12 and minus 12 get eliminated, and here 6 and 6, here also we have 12 and 12, and therefore we doesn't have any denominator. And by doing the simple calculation, you will get the y of 2 is equal to 4. Naveen, Naveen, and do you have any doubts over the interpolation, Lagrange's interpolation? The application over the Lagrange's interpolation is when we have the unequal intervals over the x. At that time, we need to depend the Lagrange's interpolation in order to find the respective y value, and vice versa. When we have equal interval over the y value, at that time we can find x. There is no need to worry about the intervals over the x. And inverse interpolation is feasible in the case of Lagrange's interpolation. Interchanging x and y the Lagrange's formula will get as similar to that of the y value. This is the inverse interpolation formula to find the x value, and this is your find the value of x when y is equal to 85 using Lagrange's formula from the following data. Please write it down. The given problem is your exercise number 4. Yes, by applying the various x and y value, yes, x is equal to 85 minus 87.9, 85 minus 81.3, 85 minus 67.7, divided by 94.8 minus 87.9, 94.8 minus 81.3, 94.8 minus 58.7 into 2. Similarly, we have the other terms. Coefficient to 5 and the coefficient to 8 and coefficient to 40. Okay. And find the solution, because I'm getting different than the textbook. I'll wait. You try to solve this particular problem. We'll cross check with the results. Please take your calculator and solve the uh, slide. See here, I am getting 5.5098, but in the textbook it was given that 6.5928. I'm keeping the slide. You try problem. I'll wait until getting the results. Please go ahead with your steps. Arvind, you can find the solution. Tell me, Arvind. Arvind, or Anand Modi, Amla Srikanth. What was the result? I think we were all very attentive. Sabrani, what was the result, Sabrani?
Sir, I'm still calculating. Sir, show that formula page once again.
Okay.
Yes, sir. Sir, I have a doubt. Sir, I have a doubt. So, like in the formula
Yes.
page, it was like y minus y1 into y minus y2. But like if you see on this page, it's yeah. So like
Yes.
we
Yes.
start from y1, right? But on this page, we started it as y minus y2, sir. So 87.9 is y2, no?
Yes. We'll check. Minus y1.
Okay, sir. Sorry, got my
Oh,
mistake.
here I have wrongly written. Again, I have written here in this particular part. Okay. Here the x naught is equal to 2 and your x1 is equal to 94.8. Your x1 is equal to 5 and your y1 is equal to 87.9.
Okay, so yeah, got my mistake.
Try to calculate each coefficient, that is the term which is associated with the 2 and 5, 8 and 14. Please make a note, and even you can say with that the coefficient with the ABCD. Once you calculate the coefficient, you can we can multiply with 2a plus 5b plus 8c and 14b, and that way we can simplify our problem. Uh, 2, okay, 1, 5, 1, 2. Okay. Instead x2 and y2 we have to write x1 y1 here. Instead x3 y3 we need to write x2 y2 here. Instead x4 y4 we need to write x3 and y3. That was wrong. That was wrong. Please aware that during uh, writing over the notes. Please write it with x1, x2 y2 and x3 y2. See, this is what I am getting the coefficient. The coefficient with respect to 2 is minus 0.0719. The coefficient which is associated to 5 is 0.6759. 15 point minus 0.0733. This is so.
Yes, sir.
But store the coefficient with A, B, C, D, or any other mean. But no, don't leave any the terms which is associated with the 719 and the 6959. That may lead to a very big error. And please try to store the data and retrieve the data accordingly. What was your result? What was your result? Arvind Roshan. What happened, Sabrini?
Yes, the answer is matching.
Which answer?
Sure.
Which answer? The 5.5098 or 6.5928?
It's a 5.5098.
Oh, okay. Okay. Do you have any doubts over the Lagrange's interpolation, whether it is interpolation or it may be the inverse interpolation? Do you have any doubt? If you don't have any doubt, then we'll have a visit over the Newton's forward interpolation, and be aware that Newton's forward or backward interpolation will assist us to find the intermittent value when we have the difference is uniform. But Lagrange is when we have an equal interval. At that time we need to we don't have any other option. We need to depend Lagrange is now to find the unknown, whether it may be x or y. When we have an unequal interval, at that time we need to depend the Lagranges. When we have an equal interval, then we need to go with Newton's interpolation, and we'll see the derivation over the Newton's forward interpolation. Let y is equal to be a given function of x, and let y0, y1, y2 be the value of y corresponding to x0 and x0 plus h. As I said, the equals this interval, the interval is equal, then that might be h. Therefore, we have x0 plus x0 plus h plus comma x0 plus 2h plus and so on of the values of x, that is y0 is equal to f of x0, y1 is equal to f of x0 plus h, y2 is equal to f of x0 plus 2h and so on, yn is equal to f of x0 plus nh. Here the independent variable or argument x proceed at equally spaced interval and the h is in constant. The difference between two consecutive value of x is called the interval of differencing. Now y1 minus y0, y2 minus y1 and so on, yn minus yn minus 1 are called the first difference of the function y, and the difference of yn values are denoted by delta yn. Let this term delta delta is an operator, and delta yn is equal to yn plus 1 minus yn. Yn plus 1 minus yn. Here n is equal to 0, 1, 2 and so on. Here delta act as an operator called forward difference operator. Delta is an operator called forward difference operator. Thus delta y0 is equal to y1 minus y0. Similarly, delta y1 is equal to y2 minus y1 and so on. Delta yn is equal to yn plus 1 minus yn. And the difference of the first difference, difference of these first difference are called the second difference. Here, the delta power 2 y0. We need to worry. We need to have an attention about the delta power 2 y0. This is not the power of delta. This is not. We have to pronounce this as to be second derivative of second difference of y0. Second difference of y0, and accordingly we need to pronounce that we need to call delta cube y0 as third difference of y0, and this is not the power of delta, and the second difference of y0 is equal to delta into delta y0 is equal to delta into y, as we know delta y0 is equal to y1 minus y0, By multiplying the delta with each terms, we will get delta y1 minus delta y0. Instead, delta y1 we can apply y2 minus y1 minus instead delta y0 we can apply y1 minus y0. Here in both the terms we have minus y1 minus y1. Therefore, we will get the second difference of y0 is equal to y2 minus 2y1 plus y0. And similarly, the second difference of y1 is equal to delta into delta y1 is equal to delta into y2 minus y1. By multiplying the delta with each terms, we'll get delta y2 minus delta y1. And instead delta y2, we can write y2 minus y3 minus y2. And instead y1, we can write y2 minus y1. Therefore, we will get the second difference of y1 as y3 minus 2y2 plus y1. And in general, see what happened. Delta power n, that is nth difference. That is not delta power n, that is nth difference of yk. Nth difference of yk is equal to n minus 1 difference of y of k plus 1 minus n minus 1th difference of y of k. And this is the general term, and the difference table is the second standard format for displaying finite differences, and is explained in the following table called forward difference table. By seeing this various terminology, it may give confusion over the solution, but by doing a simple difference over the given table, we can find the unknown in an easier way. And this is what this delta y naught is a difference of this two, that is y1 minus y naught, and delta y1 is a difference of y2 minus y1, and similarly for delta y2, and similarly for delta y3. And this is second difference of y0, and this is what the difference between delta y1 and delta y0. And second difference of y1 can be calculated with the aid of the difference of delta y2 minus delta y, and so on. Then we have the term till x4 and y4. Then the fourth difference is the last term in the table. That is the fourth difference of y0. Till fourth difference, we need to proceed. When we have the term x5 and y5, then we need to proceed till with the fifth difference. Similarly, when we have the term called x6 and y6, we need to extend our solution region with the sixth difference. And here each difference proves to be the combination of y values. For example, when we have the third difference of y0, we'll get the second difference of y1, the difference between the second difference of y1 and the second difference of y0. By applying the value of respective second difference of y1, second difference of y0, delta y2 minus delta y1 minus delta y1 minus delta y0. And by applying the value of delta y2, delta y1, and delta y0, and by applying the value of delta y2, y3 minus y2, and delta y1, y2 minus y1, delta y1, that is y2 minus y1, again delta y0, y1 minus y0, and this minus we need to the term y2, and we need to apply with y2 and y1. Therefore, that becomes minus y2 and plus y1. This minus, let it be the term minus, and here minus y1 and plus y0. And the first term will get y3 minus 2 y2 plus y1. Here we will get y2 minus 2 y1 plus y0. And by applying this minus into these three terms, we will get y3 minus 3 y2 plus 3 y1 minus y0. y3 minus 3 y2 minus plus 3 y1 minus y0. This is the third derivative of y0. And we have three different note during solution when we are solving the problem with Newton's forward interpolation, whether it may be Newton's forward or Newton's backward interpolation. We need to remember three different points that was given as a note. Will once will familiar with the we'll talk about the current affair, and we'll have a visit over the note. Okay, please share the current affair. Do you have any information to share with us? Malaysian, Maharaj, Pradeep, Nirmal. Any sweet memories over the festival? As we have enquired with the Anand Modi that anyone from Gujarat, why we have concern about sorry, not I have asked about Bihar, isn't it? Recently, the Legislative Assembly results came, and um, a new CM taken charge. And do you wish to share about that? Uh, the influence of BJP over the Bihar. Rahul, Rangarajan, Pradeep. I think everyone's sleeping. Varshita, you are from which state, Varshita?
Sir, I'm from Telangana, sir.
You are from
Hello.
Telangana.
Yes,
Oh,
sir.
fine. Like Tamil Nadu, Telangana also having heavy rain, isn't it? What about
Yes,
your place?
no, sir. In my places, there is no rain. It's so hot, in fact, in our place.
But in Tamil Nadu, in around 9 districts, the meteorology department given an alert, and in particular in 2 to 3 states they are given the red alert too. So, any positive over your chief minister, Rashida?
What, sir?
Who is who is chief minister?
Sir, Chandrasekhar Rao, sir. KCR, sir.
Chandrasekhar. Okay.
Yes, sir.
What and the capital, uh, whether the capital is fully developed, or still they are in the state of developing, or
Yeah,
that
sir.
was for Andhra. That was not for Telangana.
Yes, sir. Yes, sir. Hyderabad is developed only, sir. That was for Andhra Pradesh. And the chief minister decided to put three capitals that was going on.
The Hyderabad is belongs to Telangana, isn't it?
Telangana. Yes, yes, sir.
Telangana. Yes. And concerning Andhra.
Sir, concerning Andhra, the CM decided to have three capitals, sir, and some discussions are going on about that. People are not accepting to have three capitals for a state.
What was the earlier plan during the past opposition party? They have decided to have only one.
Yes, sir. They only
And
decided
what
to
is the
have
name of that
Amaravati as
that
capital.
place? Yes,
Amaravati,
Amaravati.
sir. Yes, sir.
Yes. Yes. Okay. Any other uh, current affairs apart from Rashida? Any other current affairs? Rangarajan, you are from
Yes, sir.
Salem, I think so.
No, sir. Kadlur district. Pandruti.
Kadalur,
Yes, sir.
Pandurti.
Yes, sir.
Pandurti. What was the status of rain?
Yes, sir. Heavy rains, sir, during the night.
Heavy rain. Yes, of course. I'm
Yes.
also in now in Delta. Usually I'll be in Tiruvambur, that is very
Ah,
nearer to NIT. Now I am in far away, 50 kilometers far away from Tiruvambur. That was my native. Here also we have rain, but that was not equal to Kadalur.
yes.
Okay, fine.
Yes.
Any other updates?
No, sir. I
Ehashpi?
don't know.
Okay, fine, Rangarajan. Ehashpi, Marikanti, Ehashpi. The 63.
Sir, actually,
Yes. You belongs to which state? Anthony?
Telangana, sir.
Oh, you too from Telangana. Okay, fine.
Yes.
Okay, again we will get back to our presentation. See, there are three different nodes we in Newton's powered interpolation, and the difference operator delta may also be defined by the equation delta f of x is equal to f of x plus h minus f of x, and where h is the interval over the x, and delta f of x is equal to as in the which was given in the text, that is f of x plus h minus f of x. The second difference of f of x is equal to delta into delta f of x, and delta, let it be delta in the outside. Instead of delta f of x, we can apply f of x plus h minus f of x, and delta can be multiplied with both the terms, that is delta f into x plus h minus delta f of x. Instead f of x we can write as f of x plus h minus f of x, but for concerning delta f of x plus h, that is f of x plus 2h minus f of x plus h, minus, as I said earlier, instead of delta f of x, we are going to apply del f of x plus h minus f of x. What was the thing we need to remember? We need to start with f of x. We need to apply minus symbol, and this is the term which is prior to f of x is f of we need to add adjoint the h over the x. Similarly, here we need to start with the f of x plus h. I am adding the h over the already we have a h. Therefore, I am adding one more h. Therefore, we are getting f of x plus 2h minus f of x plus h minus of f of x plus h minus f of x. Therefore, we will get f of x plus 2h minus 2 into f of x plus h plus f of x. This is the second difference of f of x. And similarly, for third difference of f of x, what we have to write delta into for second difference of f of x. We have already derived the second difference of f of x. I am applying the derivative uh, over the text, and I am getting the delta into f of x plus 2h minus 2 into f of x plus h minus f of x, and therefore by doing the simple calculation, and we will get f of the third difference of f of x will be the f of x plus 3h minus 3 into f of x plus 2h plus 3 into f of x plus h minus f of x, and so on. The generalized term, that is nth difference, will get the nth difference as the nth difference of f of x will be the n minus 1th difference of f of x plus h minus n minus 1th difference of f of x. And here the difference is delta f of x and the second difference of f of x, and so on. are called the first, second, third, and nth difference of f of x, as I said earlier. And the term delta y naught for second difference of y naught and third difference of y naught will be the leading differences. And the term y naught is called leading term and leading differences. We need to remember the term leading term and leading differences. And here delta is not a quantity but a symbol standing for an operation. Here delta power 2 or delta power 3 does not represent, as I said, it does not represent the square or cube of a quantity, but denotes the repetition of the operation delta. The second, we need to call the delta square as second difference of x or second difference of y, and similarly for delta cube as third difference of x or third difference of y. And concerning the fourth point, the difference of the constant functions are 0. That is delta c is equal to 0. When we have a associated with f of x, when a can be the constant, a into f of delta into f of x, and b into delta into g of x. This can be, that is delta into a into f of x plus b into g of x can be written as a into delta of x and b into delta g of x. And the constant delta is equal to 0. And with that, we'll wind up today's class. During the tomorrow's class, we'll solve the Newton's forward interpolation and Newton's backward interpolation. And do you have any doubts over the derivatives of Lagrange's or the derivatives over the derivations over the Newton's interpolation? Do you have any doubts? Do you have any doubts over the derivation? If you feel that we are very fast with the presentation, please make notes, copy the notes with the videos. Okay, we'll tomorrow we'll meet. Tomorrow 12:30 we'll meet. Thank you, Mamata.
Thank you, sir.